on a planet orbiting one of these stars and look up at night. No band of the Milky Way, no crowded constellations, just black and a single faint smudge of light where an entire galaxy hangs, impossibly far away. That star has no galaxy. It drifts alone through the empty space between galaxies, one of countless stars astronomers call orphans, intracluster stars, torn loose from the galaxies that made them and left to wander the dark on their own. When we map a galaxy cluster, we expect bright islands of stars separated by near total darkness. Hundreds or thousands of galaxies, each a tidy package of light, with cold, empty vacuum stretching between them. That's the picture the simple model predicts. The real image is different. Fill the gaps with a long enough exposure, and a faint, ghostly glow appears, spread across the whole cluster belonging to no galaxy at all. It has a name, intracluster light, and it is made of orphan stars. Fritz Zwicky noticed it first. In the 1930s, and again in 1951, studying the Coma Cluster, he reported diffuse luminous matter drifting between the galaxies. For decades, it was mostly ignored, too faint to study, easy to dismiss as a measurement error. There's a strange symmetry here. Zwicky, who first glimpsed that glow in Coma, is the same astronomer who, studying that cluster in 1933, first inferred dark matter, realizing the galaxies moved too fast to be held by visible mass alone. The faint light and the invisible mass were tangled together from the very start, and that tangle is the reason this story is worth following. It will turn out that orphan starlight traces where the dark matter actually is. Modern surveys show it's no error. Depending on the cluster, orphan stars account for somewhere between 10 and 40% of all the starlight. A vast population belonging to no galaxy, in some clusters rivaling the stars still bound inside them. The reason it stayed hidden is brightness. Intracluster light is often less than 1% of the brightness of the night sky seen from Earth. Detecting it means teasing out a whisper of light from an ocean of background noise. In 1998, a team using the Hubble Space Telescope, led by Henry Ferguson, directly detected individual intergalactic stars in the Virgo cluster, red giants glowing in the void between galaxies. It was the first clear proof that stars really do live out there, alone. To even count these stars, astronomers use tricks. In the Virgo cluster, teams led by Magda Arnaboldi and Ortwin Gerhard hunted for intracluster planetary nebulae, the glowing shells of dying stars, floating in open space between galaxies. Each one marked a star with no home. They found more. Individual red giants picked out in the empty reaches of Virgo. Supernovae exploding far from any galaxy. Every detection confirmed the same unsettling fact. The space between galaxies isn't empty. It's thinly populated with the dispossessed. The orphan population tends to be old and red, stars that formed long ago inside galaxies before being stripped away. They carry the chemical fingerprints of the galaxies they came from, so their makeup is a record of which galaxies were torn apart and when. The Hubble Frontier Fields program, running from 2013 to 2017, stared at massive clusters long enough to map their intracluster light in detail. Deep exposures revealed the glow wrapping around and between the galaxies, like a tide that had washed through and left stars stranded. One of the most studied is Hubble 2744, nicknamed Pandora's Cluster, a violent pileup of at least 4 smaller clusters. Its intracluster light is bright and messy, exactly what you'd expect from a system caught mid-collision. shedding stars in every direction. A star loses its galaxy mostly through violence. When galaxies fall into a cluster, the cluster's gravity and the pull of neighboring galaxies stretch them, tearing off long streams of stars. Over billions of years, those streams dissolve, and their stars scatter into the general glow. A star doesn't leave its galaxy in an instant. Tidal stripping can play out over hundreds of millions of years, the galaxy slowly unraveling as it falls inward, until stars that were once part of a spiral arm are simply gone, folded into the cluster. In nearby clusters, we can still catch the process in the act. Long, faint streams and plumes of stars trailing between galaxies, tidal tails that haven't yet dissolved. Given enough time, each of these will smear out and vanish into the diffuse glow. Some orphans come from the biggest galaxy in the cluster. As it grows by swallowing smaller galaxies, stars spill off during each merger, building a bloated envelope of loose stars around it. Others are stripped from dwarf galaxies, shredded completely as they plunge inward. Not all of it happens inside the cluster. Some stars are pulled free earlier, while their galaxies are still in smaller groups before those groups ever fall in. A head start on becoming an orphan that astronomers call pre-processing. Cosmological simulations like Illustris TNG try to reproduce this, growing virtual clusters and watching where the orphan stars come from. The results don't fully agree with each other or with observations on which process dominates, a sign we still don't understand how the glow is built. Here, the disagreements get sharp. There's no clean line between the outer stars of the central giant galaxy and the intracluster light around it. The two blend smoothly. Some researchers argue they should be measured as a single component. Others insist on separating them. Different choices give wildly different fractions. That's why the origin of orphan stars matters, and why it's still argued over. If they trace dark matter, understanding exactly how and when they were stripped tells us about the growth of the entire cluster. But teams still disagree on the balance between mergers, stripping, and pre-processing. The glow also grows. Simulations and observations agree that the fraction of orphan stars has climbed over cosmic history as clusters assembled and tore apart more and more galaxies. The intracluster light is, in a sense, a scar that deepens with every merger. The scale is hard to hold in mind. A single large cluster can hold trillions of these wandering stars, spread across millions of light years. Some may be truly alone, their nearest neighbor, a star thousands of light years off across the void. One measurement reshaped how astronomers see this light entirely. In 2018, Mireia Montes and Ignacio Trujillo studied 6 clusters from the frontier fields and showed the orphan stars trace the invisible dark matter. The glow follows the hidden mass more faithfully than the bright galaxies do. The implication is unsettling. Dark matter is the unseen scaffolding holding clusters together, normally detectable only by its gravity. Yet these discarded stars, drifting free, settle into the same shape as the dark matter, turning the faintest light in the universe into a map of its darkest structure. Recent measurements of the Coma Cluster suggest its orphan stars may make up roughly a third of its total starlight, nearly 100 billion suns worth of stranded stars, drifting where Zwicky first suspected something was hiding almost a century ago. New instruments are aimed at the problem. The James Webb Space Telescope has detected intracluster light in distant clusters, seeing the glow as it was billions of years ago. And Euclid, launched in 2023, is mapping this faint light across huge areas to trace dark matter on the largest scales. The Vera Rubin Observatory, beginning its 10-year survey of the southern sky, will image thousands of clusters to a faint depth, mapping Orphan star light across the whole population rather than one cluster at a time. These stars will not fall back. Cut loose from their galaxies, they drift outward, cooling and fading, orbiting the empty center of the cluster for the rest of cosmic time, a slow, diffuse ember of everything that was torn apart to build it. How much of a cluster's light is truly orphaned, and exactly how it was stripped away, is still unsettled. So is the biggest claim of all, that this faint diffuse glow is the most honest map of dark matter we have. Euclid and Vera Rubin will measure Orphan starlight across thousands of clusters in the coming years, and either confirm that link or break it. Which way it falls is the question worth watching. Subscribe for more from the dark between the galaxies.